Coupled motion occurs when two things are attached to each other. So let's say you have a guy on rollerblades and his dog is pulling him. The man and the dog are both connected by a rope. So their motion is coupled. So if the dog is moving with velocity vd, the man is moving with velocity vman, and they're connected by that same rope, well then the man and the dog are moving at the same speed. So this can be, this coupled motion can often be over a pulley. So let's say we've got a block here and then a block here. And then they're connected by a rope that goes around a pulley. Well, B is moving at speed of VB, A is moving at speed of VA. They're connected by the same rope. We know that VA equals VB. Because however much B moves, A is going to move by that same amount. But it can get a little trickier. Sometimes things can be connected by the same rope, but not moving at the same speed. So an example of that is there's a person, this is a bird's eye view, and let's say they're doing the discus throw. So they're holding their discus ball and it's connected by this little chain here. Person is swinging in a circle. And so the discus ball is also going in a circle. The person's not moving linearly. It's not moving in space, it's just rotating around. But the ball is moving pretty fast. So this is the case where they're connected by the same rope, but they're not moving at the same speed. They have the same angular speed, but not the same linear speed. And then if we have a situation like this one with the two blocks, we could have something like B is here, A is here, and instead they're connected like this. There's no pulley. While B is moving this way, A is moving this way. They're not necessarily moving at the same speed, because when B is way back here and A is just starting, if A is passing down this point, A is moving, B is still. And then as A moves further and further down, B gets going faster and faster. So this is another case of coupled motion where the speeds are not the same even though the rope is the same. So we'll learn how to calculate all about these kinds of things. But one very common application of coupled motion is a pulley system. So I'll say this is coupled motion. Now, pulleys. If a pulley is connected to something by the same rope, the easiest thing to do to figure out velocities, so let's say this is block A, it goes over a pulley, somebody's pulling on it. The easiest thing to do with pulleys to figure out how fast the relative motions are is just count the ropes. So in this situation, A is moving up at VA, P is pulling down at VP. There's one rope connected on A, one rope connected on P. 1A equals 1P. VA equals VP. This is for speeds. Obviously, they're moving in opposite directions, so if it asks you for velocity, no, you'll have to take the sign into account. So let's look at another one. So let's say here's a block hanging here. Call it M for mass, and it's connected to a pulley. And then there's another pulley hanging from the ceiling. And here's the rope. Comes down. And then somebody is pulling on it here. Well, M is going up, VM. P is going this way, VP. So now we count the ropes. Well, there's one rope total, but how many pieces of the rope are pulling on M? We have M is connected like this, so there's two parts of the rope are pulling upwards on M. Well, P only has one part of the rope. So that's the relationship there. Now, if we look at another one, so let's say we have one pulley hanging down, we have another pulley hanging down, and then we have block B. Say B is got pulley going there, and then let's say the rope is connected to B down here. It goes over this pulley, under this one, over this one, and then somebody's pulling down. All right, well, there's still one rope, but let's see how many parts of the rope are pulling on B versus on P. Well, B has one pulling up, and then here it's got 2 and 3. So 3 parts of the rope are pulling up on B. Now on P, again, only one part of the rope. All right, so this method I'm teaching y'all here, this is a shortcut method. The book uses math to do it. And so if you want to learn about that, you can read it in the book. But seriously, the fastest way to do this is just count the ropes. You can get the relationship. Sometimes things can get more complicated. If it gets really complicated, you need to use math. But then if it is going to be really complicated, just don't bother. You know, build yourself a different type of transmission. Keep things simple. So we're not going to go into the nitty-gritty details of all that. Now, sometimes for a pulley system, there are multiple ropes. So this is where it gets a little more complicated. Let's say we've got this. And there is a pulley hanging down here. And then there's block A is hanging here. And then let's say there are a couple other pulleys. And then block B is hanging from this pulley. And here's a rope connecting. So let's say the rope for A starts here, goes under this pulley, over this pulley, connected to A. Now the rope for B is connected here, and then it's connected to the ceiling. So if A goes down, B is going to go up. We can kind of tell that. But how do we know what their velocities are relative to each other now that there are more than one rope in the picture? Well, since there's two separate ropes, we just need two separate equations. And then we'll relate them together. So the first thing we need to do here is look at this point where the two ropes meet. So both ropes involve this middle pulley right here. So we'll call this one C. We're choosing this pulley to be kind of like our intermediate equation variable because that's where the two ropes are joining. So for this first one here, we can see on C, the rope is connected in one spot, and on B, the rope is pulling in two spots. So 1C equals 2B, BC equals 2BB. Now on this one, A is getting pulled in one spot, and C is getting pulled in two spots by that green rope. So VA equals 2BC. So if we want to find how A and B are related, we can just plug in. So here we know that VA equals 2 times BC, but BC equals 2 times BB. So 2 times 2BB equals 4 BB. VA equals 4 BB. So to do pulley problems, you just count the number of ropes. You need one equation for each rope. And then you see how many places the rope pulls on the block. You write that down, and then that indicates the velocity ratio.